Did you know that the first black hole discovered by humanity completely changed our understanding of the universe? And the most surprising part is that what we thought we knew about these cosmic monsters is being rewritten with new discoveries. Get ready for a journey into the unknown. Black holes are one of the final frontiers of human knowledge. From the first detection of Cygnus X1 to the stunning image captured by the Event Horizon Telescope, our understanding of these gigantic cosmic enigmas only grows. But at the same time, new questions arise. What lies beyond the event horizon? What happens at the singularity? And how do black holes connect to the other great forces of the universe? The only certainty is that the more we discover, the more we realize how much there is left to learn. But what do we really know about black holes? And more importantly, what don't we know yet? What do these mysterious giants hide, and how has our understanding of them changed over time? Let's start at the beginning, with the discovery of the first black hole. The idea of black holes goes back long before we had the means to detect them. In the 18th century, British physicist John Michell first suggested that there could be stars so massive and dense that not even light could escape their gravity. But it wasn't until 1964 that we were able to identify a possible black hole for the first time. This black hole was Cygnus X1, located in the constellation of Cygnus. The discovery happened through intense X-ray emissions detected by astronomers. Since a black hole itself doesn't emit light, it was this radiation that gave us the first clue of its presence. Cygnus X1, devouring matter from a nearby companion star, was generating immense energy, resulting in the X-ray emissions we observed. This was a crucial milestone. For the first time, we had clear evidence of something so dense and powerful that, even without emitting its own light, it could be detected by its effects on its surroundings. From there, the race to understand these mysterious objects began to accelerate. Now, before we dive into the most recent discoveries, have you ever wondered what a black hole really looks like? The movie Interstellar brought us one of the most realistic representations, thanks to the collaboration with theoretical physicist Kip Thorne. The scientific accuracy in the design of the black hole in the movie gives us a fascinating glimpse of how these objects might actually appear. But as visually impressive as it is, Interstellar also made us reflect on the unsolved mysteries of black holes. What is a black hole? To understand better, we need to demystify what a black hole actually is. Essentially, it's what remains when a massive star reaches the end of its life. When these stars burn out their nuclear fuel, they collapse under the weight of their own gravity. The collapse is so violent that all the star's matter is compressed into a single point called a singularity. This singularity has such intense gravity that nothing can escape it, not even light. The surface of a black hole is what we call the event horizon. Everything that passes this point can't return. This boundary marks the limit where the gravity of the black hole becomes irresistible. That's why we can't see inside a black hole. Information simply can't escape. The movie Interstellar depicts a massive black hole called Gargantua, which is surrounded by an accretion disk, made up of matter falling into the black hole, generating an immense amount of light and heat. This representation aligns with what we know about supermassive black holes, which are found at the center of nearly every large galaxy, including our Milky Way. The first image of a black hole, a historic moment. In 2019, the world witnessed a historic milestone in astronomy. For the first time, we captured an image of a real black hole. Thanks to a global network of telescopes known as the Event Horizon Telescope, EHT, scientists were able to photograph the supermassive black hole at the center of the Messier 87 galaxy, about 55 million light-years from Earth. This image, which became famous for its bright ring of light around a central shadow, was the first visual confirmation of what many scientists had believed for decades. What we're actually seeing in this image is the shadow of the event horizon. The visible light comes from the accretion disk around the black hole, where gas and dust are being pulled toward the singularity. This image confirmed many theories and models that physicists had been developing for years. Recent theories and our current understanding. Since this first image, science has advanced rapidly in its understanding of black holes. Today, One of the main areas of research is the connection between black holes and quantum gravity. Stephen Hawking had already suggested that black holes weren't completely black and that they emitted radiation, what we call Hawking radiation. This phenomenon has not yet been directly observed, but physicists are working intensely to discover how it works. Another recent field of study is what we call primordial black holes. Some scientists believe that small black holes may have formed right after the Big Bang. If this is true, these black holes could be responsible for the mysterious dark matter that makes up a large portion of the universe. We are still far from confirming this theory, but the implications are huge. The impact of black holes on general relativity and quantum mechanics. Black holes also challenge our understanding of the laws of physics. On a cosmic scale, they obey Einstein's general theory of relativity. But on a subatomic level, where quantum mechanics rules, things get much more complicated. The singularity of a black hole is a point where the known laws of physics break down. This is one of the greatest challenges of modern physics, unifying general relativity and quantum mechanics into a single theory that fully explains the universe. Black holes are at the heart of this quest for a theory of everything. Now, let's get to the most intriguing question. What happens inside a black hole? The truth is, we still don't know. The singularity, where density is infinite and time and space become indistinguishable, remains a mystery. Will we ever be able to send probes or develop technology to explore the inside of a black hole? Or will certain secrets of the universe remain forever out of our reach? As Interstellar illustrates, the extreme gravity around a black hole distorts space and time in ways we are still trying to understand. But what about sound? Can we hear a black hole? In 2022, NASA released something truly astonishing: the sound of a black hole. Using data from the Perseus galaxy cluster, scientists were able to translate pressure waves generated by the black hole into sound waves. The result? A deep, eerie, almost haunting sound, like a low hum resonating through the cosmos. It's unlike anything you've ever heard on Earth. This sound isn't a typical sound as we know it, since space itself is a vacuum, but it's a representation of the cosmic forces at work. A reminder of the immense power and mystery surrounding these celestial giants. Imagine standing on the edge of the event horizon, listening to the distant echoes of the universe as the black hole warps time and space around you. It's a chilling and awe-inspiring thought, but it also reminds us of just how much we have yet to learn about these enigmatic forces of nature. Black holes are one of the final frontiers of human knowledge. From the first detection of Cygnus X1 to the stunning image captured by the Event Horizon Telescope, our understanding of these gigantic cosmic enigmas only grows. But at the same time, new questions arise. What lies beyond the event horizon? What happens at the singularity? And how do black holes connect to the other great forces of the universe? The only certainty is that the more we discover, the more we realize how much there is left to learn. If you want to keep exploring the mysteries of the universe, subscribe to the channel and stay tuned for the next videos.